I'm currently at ThoughtWorks in kind of like a global subject matter expert or developer advocate, team advocate role for how we use AI tools in the creation of software. So not about like, building AI into the products we're building, but how do we use it as a tool to get better at delivering software? And as you probably all know, it's a very evolving field right now, right? And I often see people struggle staying on top of it. And I can tell you, I have this as a full-time job, and I cannot stay on top of it. So you don't have to feel bad. But what I'm trying to do with this presentation is to just give you an update, right? Like, where are things right now? Maybe also what happened in the last 2 years. And I always try to get the skeptics among you more enthusiastic and the enthusiasts a little bit more down to earth. So let's see if I can manage that. So I'll first go into a quick history of features of AI coding assistants. So it all started with kind of this autocomplete on steroids, right? So we could start, this is a screenshot from GitHub Copilot, relatively early on, maybe, 1.5, almost 2 years ago, where you could write like a comment or a method signature, and it would give you these suggestions, the same as your normal autocomplete, just like slightly bigger, let's say, right? So here in this screenshot, it's actually suggesting a full function to me. Then we got a chat embedded in the IDEs with Copilot as well, or this is a tab 9 screenshot. So I could start asking you questions like, I'm a Java developer, that's my mother tongue, so to say. So when I started writing Python, I would ask stupid questions like, is there the concept of a static function in Python? And I didn't have to go through my browser, scroll through lots of results, scroll through lots of ads and find the information, which was already quite convenient. And then it kind of evolved to even more IDE integration. So here you see an example of, in GitHub Copilot, of getting like this, fix this error using Copilot or explain this using Copilot. And we could also start more specifically pointing at here at files in our code base and say, okay, I'm working on this particular file, please help me improve that. Or here you can see then the next evolution of this was that we don't even have to write the comments anymore to prompt, but we have small little inline chats inside of our editor where we can say what we want to change about a line, and then we get a diff suggestion and can accept or reject that. Then it evolved even further, and the chats became even more code-base aware. So we could start asking questions about our code base or chatting with the code base, as you can also say. So here's a screenshot of Cursor, another coding assistant, and you can see here I was asking a question in a code base that was unfamiliar to me. Can you see any tests for this particular drop-down box? If they are, introduce a test, and et cetera, et cetera. And in the background, actually, the tool is turning this into a search query that is querying the index of the code base that the tool has created inside of the IDE. And it's actually quite interesting because this is the space where many of the tools actually implement this differently. So in Cursor or in GitHub Copilot, you have an index of your code base. There's a tool called Cody that actually uses a code search product to get this coding context, or tools like Klein or RuCode, they actually use the file tree and the abstract syntax tree to find things. So there are a lot of different approaches to this code search to integrate into the chat. And then almost finally, we also got more context providers. So additional sources of data that we can pull in as a developer to give the AI or the large language model more context of what we're working on. So you see some examples here from different tools. These screenshots are about a year old probably. So it's pointing at things like you can add a URL of a web page, for example, maybe where the documentation of your library is, or you can even point at specific reference documentations or at the Git diff in your current workspace, et cetera, et cetera. So, and the more of those there were, and the more as a developer I'm aware of them and can pull them in, the better the results were sometimes. And of course, the whole time as these features were evolving, the models were also evolving, right? So there's no way to show you a complete history of all the models that people considered for coding, right? But, every second or third week, there was like, oh, this model is even better than GPT-4. And, so it was like very busy space, right? So these are just it's like some of the evolution, right? So it started with Codex and GitHub Copilot, which was based on GPT 3.5 and kind of evolved from there. And at this point in time, actually for a while, so this is one of the things that has been relatively stable, the favorite model for coders to use for AI assistance is the Claude Sonnet series from Anthropic. And even though there are some models that are now also getting to similar usefulness, this is still like a really, really good default. So when we had these features, the unit of AI assistance that I get at the time is kind of the size of, let's say, a method, maximum a method, right? Sometimes we would get one line of code suggested, or 2 or 5, or sometimes a whole method, like you saw in my very first screenshot. But that was kind of like also made me feel like I'm still in control. You know, I'm going step by step. I'm kind of reviewing this as I go along, right? And the favorite, like the most frequently asked question that I then in my role always got was from engineering leaders. Well, what's the impact? How much %, right? And so what that usually talks about then is speed, right? Because that's maybe one of the things that we can kind of measure. And the proxy variable for speed is cycle time, the best one we can use, right? And I've always kind of used this heuristic to see like how much impact does this actually have in terms of the ballpark, right? So if you think about the part of the cycle time that you spend on coding is actually not 100%, right? So let's say in a very optimistic scenario, the team spends 40% of their time on coding, which is actually relatively high. And then let's say the part of the coding that they're doing that is supportable with the coding assistant is about 60%. And then let's say the rate of faster task completion is the famous GitHub 55%, right? Which was the number that was going around all of the C-level suites, right? And then they said, oh, we can cut our teams in half, right? But so if you look at this, then that would have an impact in this scenario of 13% on your cycle time, which you might not even see because cycle time is often quite variable, right? But it's still like, if this is actually happening, then I think that's actually quite good, right? Just because we're anchored on the 50% doesn't mean that this is not good, right? But Gen AI tooling is a moving target, right? So I've been using this heuristic to get a ballpark, and also seen a lot of confirmation of this at our clients. Like whenever teams were doing an effort at estimating how much time it saves them, it was always kind of in that ballpark, like 8%, 10%, that kind of size. But tools are constantly evolving, so you never have a good basis then to compare it to what is happening next. And now it's changing again, right? And one of the biggest kind of step changes that has now happened over the last few months that kind of like maybe, you know, changes that whole heuristic again is kind of the entrance of agents or agentic modes in the coding assistants. And I put supervised in brackets here. You'll understand a little bit better later, but what I'll talk about here exclusively is agentic modes in the chat functionality in coding assistants where I, as a developer, am still in charge. I'm supervising, I'm intervening, I'm changing, no, don't do that, change that again. And I'll not be talking about the agents that actually autonomously go ahead and try to like implement a whole feature for you, because I've never seen that work once, to be honest, not even in the marketing videos. It maybe works for like very small things like, oh, the build failed, and it's like a very obvious kind of like thing, and it kind of automates the fix for me, but not for like larger things, right? And so these are some of the tools in that space. And I put Aider and Klein, those are both 2 open source tools. I put them very much on the left here because they were kind of like the first ones. They did something like this of like actually editing multiple files for you and not just like a few lines of code. And then other like big players here are Windsurf and Cursor, and of course, GitHub Copilot as well. Though the last time I gave this presentation 2 weeks ago to the day, I said GitHub Copilot's agentic mode is still in preview, and then an hour after my talk, I saw the announcement that they made it generally available. So it's always a danger when you give a talk on this, it's already outdated 1 hour later, right? So, but yeah, these are kind of like some of the prominent ones that have the agentic modes, and the circled ones are the ones that I worked most with and compared, and I usually use Claude Sonnet in them to kind of have like a stable baseline, and at least the model is stable when I compare them, right? And so now what's happening is that the unit of AI assistance I can get at a time is suddenly growing, right? So I can actually throw a quote-unquote problem at it, and it will help me solve it. And I put the question mark here behind the problem because a problem can be a lot of different sizes, right? And I'll talk a little bit more about that later as well. But before I dive into what these features actually look like, let's talk first about what agent even means, right? So this is quickly becoming one of those terms where you always need a qualifier in front of it, same as service, right, or test. Those can mean very different things. So in the context of a coding assistant, what an agent is basically inside of the coding assistant, you have multiple functionalities available, right? Like reading a file, changing a file, executing a command, running tests, and so on, right? And so now when the user or when the coding assistant puts together a prompt for me for the large language model, like here's the user's request, and then it also says, and by the way, you can use the following tools if you need them. You decide if you want to do that. And then the large language model might return, oh, run yarn test, please, and give me the results. And then the coding assistant will run that and return it back to the large language model. And this is how agents work in general, right? So you always have a request that tells the model, here are tools that you can run. And the model doesn't really run them itself inside of its runtime, but it tells its caller, like, please run these things and tell me the results, right? So here's a very simple example. So this is in Cursor. I know you can probably not read the exact things in the back, but basically what I'm asking is to do a small implementation and also change the corresponding test. And so it can read multiple files, which like a few months ago in most coding assistants wasn't possible, and change multiple files at a time. Now it's modifying the actual code. It did the test first, but it didn't stop to let me look at the test. And now it's actually running the test command. And it's concluding, oh yeah, the test has passed. We're done, right? This is, of course, a lot more powerful as well when you actually have failing tests, right? And it can immediately pick up on the failures, and it just immediately goes ahead and tries to fix the failure for you as well, where previously I might have just copied and pasted the error message over, so it was a lot more cumbersome. So this is kind of like more automation almost, right? Sometimes it's very trivial and obvious what I want to do next, like run the test or fix the test or something. And those types of things, like AI is now really good at picking up and automatically doing that for me. Here's another example. So this is Windsurf this time. And Windsurf is actually now going and doing some web research for me to fix like a compatibility problem I have here between two libraries. So it's actually going out on the web, doing the research for me, then suggesting to add a library. So it's suggesting this terminal command that I can now accept or reject, which is also super helpful, right? Again, that is something that I would probably do manually otherwise. And this also now gives me more confidence that it actually has up-to-date information, right? And then finally, here's an example that I also really like because it shows the power of integrating a token-based large language model with the IDE that understands the code, right? A lot of these agentic modes also have integration with the linting, compile, transpile errors that the IDE picks up on. So it can actually, in this particular case, I think the large language model added something to my file that made it not even parsable. So it introduced some kind of syntax error. And then it can actually automatically pick up on that and fix it, whereas before I would have to shout at it. So again, it's kind of like a nice automation improvement from before, where I had to say, hey, that doesn't compile. So this was me trying out a similar functionality in GitHub Copilot last year in November, I think. So now very frequently you just sit and kind of stretch and kind of like watch it do its thing, right? And and I use it all the time now, not just because it's my job, because I actually really like using it. And it's even when I give it like very specific plans where you might say, oh, but can't you then just write the code yourself if you already know exactly what it's supposed to do? It's kind of very nicely reducing my cognitive load because it's finding the places in the code and changing them. And it sometimes also helps me think through a design. I just let it go and then I see, oh, yeah, no, that doesn't work. Let's just revert everything and try again. And it helps me solve a lot of issues much faster. And before I get to what the catch is, or what the catches are, because there are catches, I just want to finish the feature tour and talk about a few other features that are now a lot more relevant in this agentic context. So one is MCP. Who here has heard of MCP? Probably it's been really exploding recently, yeah, but it's definitely not everybody. So MCP stands for Model Context Protocol, and it's a standard that was defined by Anthropic to help kind of in the interface between an agent and its extra data sources or extra things that it can do, right? So what happens now is that on my developer machine, for example, I can add like a bunch of MCP servers that run on my machine, which are basically just like programs that run on my machine. There's also remote versions of this, like let's say in your enterprise you provide one of those, but at the moment most people use them by running them on their machine. And so I can get extra functionality that I can pass to the model, right? So like use the browser or search Confluence, query my test database, add a comment to a Jira ticket, right? With my authentication and all of that. And so then basically these tools also get passed to the large language model, and it can then go back and say, let's say in the debugging process, it will say, okay, run this SQL query in the test database and give me the results. So I can then, continue with that information when I do my debugging. So here's an example of that with browsing the web functionality. So this uses an MCP server called Playwright MCP by Microsoft. And you see on the right a coding assistant going through, and I told it to kind of explore this application and create a description of the application for me in a markdown file. So it basically uses Playwright under the hood to understand what is the structure of the pages. So I was using this in the context of thinking about reverse engineering in the legacy space. Would this be useful? Or, like experiments like, can this maybe do some exploratory testing where it tries to break some things in a way that I hadn't thought about? Be careful though, these MCP servers at the moment are really like the wild, wild west, right? So you run them on your machine, you would maybe clone somebody else's implementation of an MCP server that calls Confluence or something, and you just run them on your machine, you let an agent just call them, and your machine has access to like the golden goose, the software supply chain, right? So there's a lot of security considerations here, and everything's moving really fast right now, and a lot of people are using this without thinking about that. So I'm very, very sure that will get more mature, and there will be more consideration about this. But at the moment, just treat it like any other dependency, right? There can be statements in here that maybe generate something into your HTML code, the script tag that just calls like a malicious server or something like that, right? So just be a bit careful, which is why, for example, I used an MCP server in the demo before from a source that I trust, Microsoft, right? That's how we usually kind of assess if we trust a dependency or not, right? With those kinds of criteria. Another feature that now becomes more important but has been around for a while is custom instructions or custom rules, it's also sometimes called. And again, most of the prominent coding assistants have this at this point. So you can, for example, in your project, put a file into your workspace that you can also commit and share with your whole team that says things like the backend code is Python and it's in the following folder. The build system is Poetry. Remember to activate the virtual environment before any Python or Poetry command. So I put that last statement in because I saw the agent constantly forgetting about that and then trying to pip install stuff. So this is basically like just to remind them, to remind the tool to do that. And it usually on this particular one, it actually picks up on that pretty well. And every time I start a session with the agent, the assistant kind of sends the large language model these instructions as well. So this is how I can kind of like customize for common failure modes in my particular code base. You can also put some global ones that are maybe a bit more specific to yourself. Like I tried things like be short and concise, I'm an expert and don't need too many details. Or I've also been experimenting with kind of almost like natural language commands, right? So I would say like, when I say /wrap-up, draft a commit message for me and remind me to just like restart the server just to make sure that it really starts because there were some gaps in our testing at the time, which is also like quite working quite nicely. But again, there are no guarantees. Like if you think that this will like solve all of the quality problems with large language models generating code, there are no guarantees that they will pick up on this, right? I don't know how many of you have typed something like this into ChatGPT or Copilot, like important, please always do the following, always, always, always. Why don't you listen to me, right? So it's sometimes like begging the model to do what you want, right? So, and the later in the conversation, in the session you are, the less likely that it will pick up on all of the things that you told it in the beginning. Because even if technically the context windows are getting a lot bigger, the longer a session gets, the more hit and miss it is, like how many things the model actually pays attention to. So it still plays a huge role how long your conversations are. And then secondly, just imagine like putting something like this into your instructions or custom rules. Follow JavaScript best practices, right? How do I know that that works? How do I know the model, the large language model and its training data, they have the same idea of best practices in JavaScript than I do, and that it can actually apply that to my code, right? So it's something to just be a bit careful of and experiment with a little bit, because we probably don't have time to test all of these over and over again if they really work, right? But just something to keep in mind. So the more specific you are, the better it probably works. But again, wild, wild west, right? So there was recently a vulnerability published called the rules file backdoor, where they found that with certain hidden characters in these rules, you can actually, again, like send malicious instructions to the large language model. And because people are sharing these custom instructions with each other on the internet a lot, so there's GitHub repositories and there's like whole websites that were built to share this with each other, like here's good custom instructions for a Next.js stack and stuff like that. So if you just copy and paste these from the internet and a malicious actor puts something malicious into these, then again, you might have a problem, right? And then finally, in this section of the talk, I'll talk about some ways of working that are emerging and that people are typically using with these agents. So the first one is to, before you start a session, instead of just writing one sentence of what you want to kind of do some planning with the large language model first. To kind of say it, let's make a plan first, and then, also like correct what it's actually saying. So then that's a chance to even like plan with them on a like more strategic level and see if it quote unquote understands what I meant, and correct and steer. Also, I was talking about the context window. So small sessions can also be quite important, not just if you're using an API key where you pay as you go, because the longer the session becomes, the more expensive it becomes for you, but also because of the attention thing I was talking about before. And so sometimes it's almost like have you tried to turn it off and on again, right? If it doesn't work and your session is really long, have you tried to start a new session, right? And give concrete instructions, right? So, for example, instead of saying, make it so I can toggle the visibility of the edit button, go add a new Boolean to the database, expose it through the following endpoint, and toggle visibility based on that, right? So it's like a short example for the purpose of the presentation, but maybe you get what I mean by more details. And this second box, this add a new Boolean, expose it, and so on, that might be the thing that I come up with together with the AI in the first step where I do the planning. And to make all of this a little bit easier, like to combine the planning with the small sessions problem, a lot of people are now starting to use what is commonly called memory, like either built into the coding assistants, although not so many have that built in natively yet. But let's say you say in your planning stage, put the plan into a markdown file and always update it on the way. And then whenever I start a new session, I actually have the context that was kind of created in my previous session in a markdown file, so I can point the coding assistant at that. So that's like a very common thing that people are doing right now. Yeah, so I'm starting a new session and then just pointing it at that. So now how does that change our heuristic potentially? So this is the heuristic I put up earlier, right? The very optimistic scenario of the impact of a coding assistant on cycle time. So what if we say now, let's say with agentic assistance, we can push this dial up to the task completion dial, right? It is maybe 80% faster in some cases, right? Just for the sake of argument, this is all scenario planning, right? You could also think about what, the part of coding supportable with coding assistants, like they also often stumble across the same things that humans stumble over, right? Like lack of modularization, spaghetti code, like AI is also worse at dealing with that than it is with a well-factored code base. So if you have that, maybe the part of coding supportable with it is higher, right? Or like when you have, when you choose a tech stack that is more prevalent in the training data. And then finally, what if you improve the team's processes and work environment to reduce friction so they can actually spend even more of their cycle time on coding, right? So I'm showing you these to also show that, AI is not the only solution, right? Like some of these things you cannot fix with AI, right? They are problems that we've always had about friction on teams. Coding is not everything. And there's, of course, also, using AI for tasks other than coding. And if you want to learn more about that, then same time, same place tomorrow, I'll give a talk about doing that. Oh, and also, this should also show you that this percentage number that everybody wants to know, is it 30%? Is it 10%? Is it 50%? It's not even that useful, right? If you think about how many factors are involved in this that can reduce the relative number of how much impact a coding assistant has depending on your existing environment, right? It's not even that useful, but it maybe gives us a ballpark. Okay, so stepping back from those feature details, the internet is now full of videos like this one, which is this is now me building Snake, the Snake game with windsurf. And this literally took 2 minutes in the original video. I think I sped it up a little bit, of course. So the internet is full of videos like this, and then everybody going, oh my God, in 3 to 6 months, AI will be writing 90% of the code software developers were in charge of, right? So basically, I don't have to sit in my chair anymore. So do I agree with that? Do I think I will only have to be in charge 10% of the time? I think it depends a bit on what this means. AI writes the code, right? So it's, as always with these statements, it's a little bit weaselly. You can, in hindsight, always redefine it in a way that it's true, right? So does it mean it types 90% of the code? In some cases, it does type 90% of my code right now, but it couldn't do it without me. Does it mean it does so fully autonomously or, without any of my intervention? And one term in particular captures this moment in time and this debate, which is, of course, vibe coding, right? And look at this date. So this tweet that defined vibe coding for the first time is from February 2nd. That's like, what is it, 2.5, 3 months ago? Not even 3 months ago, right? And the definition, so this was a tweet by Andrej Karpathy, and he said, vibe coding is when you don't even look at the code, you just tell the AI what you want, maybe even using voice and not your keyboard. You iterate via prompting, until it just does what you meant. Don't look at the code. It's chaotic, fast, fun. It's not too bad for throwaway weekend projects. About 6 weeks after this tweet, probably, there's job boards on the internet for vibe coders. Probably the website was vibe coded, of course. And then also about 6 weeks after the tweet, this made the rounds. I don't know if some of you saw this tweet. Somebody said, my SaaS product was built with Cursor, 0 handwritten code. AI is no longer just an assistant, it's also the builder. Now you can continue to whine about it or start building. And I don't know if some of you know what happened 2 days later. This guy tweeted again, and he said, guys, I'm under attack. Ever since I started to share, random things are happening, max out usage on API keys, people bypassing the subscription, creating random stuff on the database. As you know, I'm not technical, so this is taking me longer than usual to figure out. For now, I'll stop sharing what I do publicly. There are just some weird people out there. So I guess we are those weird people, right? And of course, it feels really good to us, right? To see this, right? See, you cannot replace us, right? And it's a great anecdote of why vibe coding specifically in that definition might not be great for real life products, in particular when amateurs use it, right? So yeah, if we look back at Karpathy's definition, like I said, he said it's not too bad for throwaway weekend projects, but still quite amusing, right? And the interesting thing that has happened is because all the features that I described to you before, right? This more agentic, chat-driven programming, a lot of people, I think, didn't know yet that was starting to come into the coding assistants. And a lot of people learned for the first time about this through the meme of vibe coding. And now vibe coding has just become the term for agent-assisted coding, right? So semantic diffusion in super speed within 6 weeks. I think I saw this morning that O'Reilly is now publishing a book called Vibe Coding. So, and it's been 3 months. I mean, it's in pre-release, of course, but. Yeah. And the thing is, vibe coding is one of the ways in which you can use these agentic assistants. Is what, sometimes, for example, I switch into this mode for like 10, 15 minutes. I particularly do that often when I have CSS code to write, right? So I just like keep prompting it until the page looks like I wanted it to look. But then after I switch out of that mode, I do actually look at the code, and then I usually delete 80% of the CSS code because it's unnecessary. So, and I definitely think it shouldn't be a whole job title, right? It's like one of the ways that you can use these assistants. And as a profession, we still have to figure out a lot of other ways to do that. And so I also kind of like look back at something that I wrote in November 2023. So I have a space on Martin Fowler's website where I regularly share what we call memos about this. So I also invite you to read that after the talk if you're interested. But like one of those memos I wrote about this like AI teammate and maybe giving it a persona to make it easier for you to think about when you trust it, right? The same way you might have one colleague who's fresh from university and maybe you listen to their suggestions, but you have like a lower level of trust that they will actually work. Or you might have a really experienced colleague who's really good at backend, but if they give you CSS advice, you're like, oh, I don't know if I'm going to take that, right? So like we do that all the time to the people on our team. And I think that it's useful for us to assign a persona to these assistants as well. So it becomes more intuitive for us to understand when we trust them or not. And I describe this AI teammate as eager to help, very well read, but inexperienced, stubborn, and won't admit when they don't know something, right? Initially, although they've become really good at apologizing when we correct them, right? Like, oh yeah, you're right. I'm sorry about that. I don't know if some of you have heard those terms. It becomes a bit triggering after a while when you've seen it often enough. And a commonly used analogy is also intern, right? Like think of them as an intern, but an intern who has read like a lot of books and a lot of code. So the question is, do I still think that's our AI teammate now? And I think it's still pretty accurate. It's just that this guy now has like access to like a lot of things, right? And if you just let it automatically execute all those commands and actions, right? Like the test commands and so on, there's a mode that in at least one coding assistant, I think in Cursor, it's called the YOLO mode, right? So you tell it, oh yeah, you're always allowed to execute any command, right? But some of them are maybe not as dangerous. But yeah, so I think it's still pretty accurate. They have maybe become a bit more sophisticated, of course, but I still think of them this way as interns. And so it's one thing is amateurs like the guy from before on Twitter building SaaS and not knowing that they need to protect an API endpoint. But let's say we do have a professional team and we do actually have a backlog that considers things like that, right? Okay, we have to bake security in, we have to protect the API endpoints, the API keys, we have to think about cost management, security, resiliency, etc. Can we now, as professionals, just give those instructions to AI and just let it go off on its own? And I just want to give you a few examples. There's a few more on that memo space that I mentioned before. To give you more data and examples about how developer skills, how I feel like my experience and skills when I use these still very much matter, also in the small step-by-step approach. And then you can try and judge for yourself if you think we're going to be replaced in 3 to 6 months. So here's the first example. I was working with the assistant on a Docker file, on a Docker build, and it said, oh, we're hitting an out-of-memory error. Let's increase the memory limit. And I said, but wait a minute, but why? Why are we hitting a memory error? And it said, oh yeah, good question. Let's think about that. And it said, oh, we're running npm install 3 times, and it includes all the dev dependencies. Maybe we can optimize that. I was like, yes, please, let's do that, right? So it's like often these like brute force fixes, that might actually get us in trouble later on. Either my colleagues might immediately notice when I push because they're like, why is the build so slow? Or we might actually only run into it like months later and not understand anymore why we did this change. Here's another example. I was asking the assistant to merge 2 functions, so basically do a refactoring. So I had 2 functions and I felt like, oh, actually, maybe it should just be one and the parameters need to be a little bit different. And I asked it to do that and it changed that. And I said, yeah, looks good. Always very polite to the AI, our AI overlords of the future, right? You have to be nice. But I was like, but you only changed the implementation. Why are the tests all still passing when you did a refactoring and you changed the signature and you didn't change the tests? And it said, oh, they still passed because we maintained backward compatibility. The old signatures are still there, and they're calling the new function. So in this case, it was really over-eager, right? I had never told it that we need backwards compatibility inside of this file, in the implementation details of this file, but it kind of like over-eagerly did that. It's relatively easy to catch when you then look at the changes before you commit them, because that's what you should always do. So yeah, if there is a code review, it's relatively easy to catch. This could also be something that I now go and put into my custom instructions file, right? Which at this point might be growing and growing and growing with more of these kind of pitfalls. And this has happened to me not once, but at least 2 or 3 times with Claude Sonnet. Claude Sonnet seems to have a thing with backwards compatibility. I don't know why. And then tests in general are like a whole thing. So they're often like verbose or redundant. So you have like lots of assertions, which at first maybe is not a problem, but then later on you might actually get a really brittle test suite where every time you change something, 20 of your tests fail, right? I don't know who has been in that situation before. It's really frustrating. On the flip side of that, sometimes there's not enough tests, so it will only create a test for the API endpoint and maybe not a unit test for something else. It often uses too much mocking, so it will even mock the data objects that I give into the subjects under test. It puts tests in the wrong places, which is maybe not the end of the world, but makes it harder to discover and find things again later. I found it almost impossible to get AI to use red tests as a tool, or I think it would be great if I, as the developer, would have a chance to look at a failing red test that AI created, and I look at it and I say, yes, it's failing for the right reason. You understood what I meant. This is exactly what I wanted. Now go on and do the implementation. It always goes and wants to do the implementation immediately. I've maybe gotten this to work once or twice. So maybe with some more tooling, you could get it to work, but yeah, it's quite bad at that. And also sometimes when a test fails, it fixes the code instead of fixing the test. You know, sometimes a test fails because the test is wrong, but then sometimes it goes fixes the code or the other way around, right? So you have to be really like alert and pay attention of what's actually happening and not just think, oh, test is green, everything's good. And one final example about, to give you an impression of how AI can actually make the design more spaghetti and harder to maintain in the future. So this is a simplified real example of something that happened to me where it introduced a new argument to a constructor, a string argument, here a system message, and it was getting the system message from another component called a knowledge manager. But as you can see here, the knowledge manager is already a dependency of this constructor. So it was actually not necessary. Like this should actually be something that happens inside of this class, right? And so if I hadn't caught this, it might actually like kind of make things more brittle and kind of like weird in the future. So when I think about the impact radius of these, like let's say blunders or missteps or things where my experience actually plays a role and I have to catch them, and if I don't catch them, is that a problem, right? So there's like these different blast radiuses, right? Like one is just an impact on my commit that mostly impacts me as an individual or me and my pair, right? I might just be slower to commit, not faster, because AI is just not giving me code that works, right? Which is actually not that problematic. The bad code just never gets into a commit, hopefully. Then slightly bigger radius is like, what if I push something that creates friction for my team in that iteration and actually impacts other people as well and makes them less effective? For example, in that case of the build process, right, where I accidentally make the build process less effective. In that particular case, I also had to tell it, hey, wait a minute, the hot reload doesn't work anymore, which is a super important feature for web developers. So my colleagues might have, 2 hours after my commit, might have said, hey, like, what did you do? Like, I can't do hot reload anymore, or it's super slow, right? So I learned about these things because I did them wrong, and my team kind of like told me about it. It had consequences, and I learned about them. And I would hope that, you know, people in the future also learn that way. But of course, if we have more throughput with AI, you know, the question is like, in which teams can we actually buffer that with those learning experiences, or is it getting too much for the other more experienced people on the team? But finally, of course, the most insidious blast radius is the negative impacts on long-term maintainability, right? So like hard to maintain tests or tests that don't mean anything, or that like kind of more spaghetti design. And I might not even notice them right now. I might notice them in 6 months or in 12 months when I have to go back to that piece of code and change it. And this is unfortunately also the blast radius that where developer experience matters the most, and it is the most like subtle sometimes and that you might not see. And one study in this space, there are a lot of studies and numbers and clickbait on LinkedIn and everywhere. I encourage you to always look closely what those things are actually about, because sometimes there's actually nothing behind it. But one study that I find very interesting and that's showing first signs of those long-term impacts is by a company called GitClear, who are doing analysis, whose tool can do analysis on Git history and Git change data, right? So they look at number of lines added, number of lines moved, number of lines copy and pasted, and churn. So churn here is when you commit a change and it gets either reverted or changed again within 2 weeks. So which is often a sign of like, oh, we actually didn't do what we meant to be doing, right? And moved is often a good sign of like how much refactoring is being done. It's not like 100% that's always the case. But so this was data about 2023 that they published, kind of saying, you know, wait a minute, was that? Yeah, that was about 2023. They were kind of saying, oh, let's monitor this. You know, they were looking at, let me see, 153 million changed lines of code. So both from their customers and from open source repositories from Microsoft, Google, and so on. So you can see here, like the churn is actually going up quite a bit. Added is slightly going up, moved is going down, but had already been going down before then. Copy and paste is slightly going up. So they published a refresh of this data 1 year later. And so churn is going further up. Added is going more steeply up. Copy and pasted is going up more steeply. Moved is going down. So these are all signs of potentially more duplicate code, more corrections within 2 weeks, and less refactoring, right? And again, we might not really be noticing this right now. We might feel this a lot harder like in a year or so when we have to change the code, right? And assistants today are actually better at adding code than changing code. So like refactoring and stuff like that is much more of a hassle than adding code now with the assistants. So one thing you can, for example, look at is like the history of your code base and kind of see, is it actually growing faster than it used to? And is there a good reason for that? Or could it be a sign that with AI, we're actually writing more code than we should? And as we all know, each line of code that you have to maintain is part of your total cost of ownership, right? And here's like another survey that I found interesting by a security company called Harness. They asked, it was a survey with 500 engineering leaders and practitioners. And one of the numbers from that one is that 59% of developers experience problems with deployments at least half of the time when using AI coding tools. And 67% said that they spent more time debugging AI-generated code than they spent debugging code before. So that's another thing to have an eye on. Like, is our mean time to restore going up? Is our debugging time going up because we don't understand the code anymore that is being written? So in spite of all of those, I'm kind of ending on a cautionary, like kind of negative note. But remember before, like I also, on the other hand, really like using these, right? And it is in our toolbox now, and it is valuable. It's not going away, but we need to figure out as a profession how to use it effectively and sustainably, right? Sustainably in the sense of like code bases that we can continue to maintain. So in conclusion, like just a few final thoughts on working with AI agents. One is that for individuals, one of our challenges now using these is to fight our own complacency and kind of sunk cost fallacy, right? And often people ask me about, the junior developers, it's so dangerous in their hands, right? But it's also very dangerous in hands of senior developers, right? So I've been coding for over 20 years, and I feel this pull all the time that I'm like, but it works. Maybe I can just push it, right? But then often, like especially in the one code base that I contribute to where other people also work on it, I often find, no, I can't push this yet because I still have to do like further things to be responsible about this, right? And it's like a real psychological thing. And yeah, it will be interesting to see how that evolves, right? We have to be alert with this, and we have to review. And that's also something that actually a lot of people don't like, right? We like creating things, not reviewing somebody else's things, in this case, the AI, right? So there's also a real conversation, I think, about, some people saying, oh, will this still be fun? I'm doing this because I like doing this and it's fun. Like, will it still be fun, right? And think about your feedback loops. So when you ask AI to do something, before you start a session, think about, how will I find out that it actually did what I wanted it to do? Will it be purely code review? Do I have a test that tells me that? Should I write that first? So feedback loops will be a big deal here as well for us to solve this puzzle of how to use them responsibly. And you have to know when to quit, right? If you have like a feature that is like almost there, but you don't really understand how it did that, and you just keep shouting at it to like make it work, at some point when you feel out of control, just revert and start again, either yourself or again with the AI. So whenever I feel like I'm losing control and I don't understand anymore what's going on, I'm trying to at least revert to a point where I still understood that. And then as a team or an organization, one very simple thing is maybe like, go back to code quality monitoring tools, right? They are not like perfect. They're not comprehensive in like the total guarantee that they find all of the bad code, but they can actually be a good level of hygiene for us, right? And I've been in a lot of organizations where there's some like sonar cube gathering dust in the corner and nobody's really using it, because when we write the code, we think, it's fine, we're writing good code, right? But now that the machines are here, maybe we can dust those off again and run them. And they can also do things like find duplicate code and things like that. So that's maybe like the baseline level of this. Another thing that I'm seeing as like a cautionary thing, like what I mean by don't shift right with AI, is that I see, for example, a lot of tools that put AI code review into your pull request process, right? And then I always wonder, but why are we running the review in the pull request? Why is not the developer running this before they even push their code, right? So there are some of these things like pushing a lot of AI to the right that maybe you can just do further left as the developer in your IDE or so. And then finally, I think organizations need a culture where both experimentation and skepticism get rewarded, right? So there was recently also more and more articles about the pressure that some organizations put on developers about using AI and being faster with it. Like, I think the title of one article was like, AI mandates are pushing developers to the brink. So it's like titles like that. And I think it can actually be it can really like backfire on you, right? Because if you tell somebody you have AI now, you have to be 50% faster. And if they turn out they cannot be if they find out they cannot be 50% faster, they're going to start cutting corners, right? They're just going to accept those things that I showed you before because they need to be fast. They have this pressure to be faster, right? And then your code gets worse, or, there's all kinds of other ways in which you can game these speed metrics, right? And so I think it needs to be now in these transformations where engineering organizations are starting to introduce these tools, you have to have a culture where you reward both of those things. So if you're an enthusiast, don't say to somebody, why are you so slow when you have AI? And on the other hand, do praise experimentation, right? It's like, oh, that's awesome that you tried that, right? Especially with people that you usually see kind of as skeptics. Because we also have to experiment, because we can't just open the hood of this car and look at the engine and know exactly what's going to happen, right? It's non-deterministic. It's like sometimes I look at it and I'm like, I cannot believe that it could figure this out. And other days it's just like so dumb, in unexpected ways. So we have to experiment because we don't know, right? And so if you're a skeptic, don't say to the enthusiast, why would you even think that would work, right? And kind of like make them feel stupid for trying something that feels a bit more outlandish. And do praise them when they're like finding ways to bake more responsibility and like better, more realistic workflows into your processes. So I think we have to navigate the hype together, right? Lift each other up to the possibilities of AI, and also drag each other down to the realities. Yeah, that's all I had. Thank you.